All right, so welcome back. So we're going to try example 4, and we are going to determine the behavior of the function in particular. We're going to find the critical numbers. We're going to find where the function is increasing, decreasing. We're going to find where the function is concave up and concave down. So let's begin. So this is very similar to example number 3, except that the type of function that we have. But the process is very similar, right? So let's begin by finding the critical numbers, right? In this example, they kind of give us that we're gonna be able to separate into two intervals. We don't have to know that, in order for us to move to do this problem, right? That's just extra, but we're gonna move on by find the critical numbers. We know that we find critical numbers whenever the derivative is equal to 0 or f prime of x is undefined. Okay, so let's begin with that. All right, so let's find the derivative first. And the derivative of this by using chain rule is going to be 9 times the product of the power, which is 2 over 3 x minus 4, and then subtract 1 from the power. So that'll be 2/3 minus 1 is negative 1/3, right? You can put that in your calculator. 2/3 minus 1 is equal to negative 1/3. And then multiply by the derivative of the inside, which is the derivative of x minus 4 is 1. All right, so we simplify these two. These will cancel, and this will give us a 3. So 3 times 2 is 6. So 6 times x minus 4 to the negative 1/3. All right, so we found our derivative. Since we're going to find the critical numbers, let's go ahead and set it up into a fraction. So we're going to move this to the denominator. So we're going to have 6 over x minus 4 to the 1/3. This is your derivative. And since we're looking for the critical numbers, we're going to start by looking for whenever this is true. So this derivative can only be equal to 0. The only way this is going to equal 0 is whenever the numerator is 0. So we're going to say numerator is equal to 0. It's a case where 6 is set equal to 0 and then solve for x. But there's no x. So there's no way you can find a critical number from here. In fact, there's no critical number from there. So let's try the other case. When the derivative is undefined. So when would this be undefined? And if you're saying that will happen whenever the denominator is 0, you're right. So it's going to be whenever the denominator is equal to 0. We kind of talked about this before, right? So that will be whenever x minus 4 to the 1/3 is equal to 0. Now this is going to equal 0 only because you have an expression raised to a power. The power is not going to change whether this is going to be 0 or not. The only way this whole thing is going to be 0 is whenever the inside is 0. You know what I'm saying? Because you cannot have like a negative 0.5 times negative and raised to the 1/3 to give you 0. The only way this is going to be 0 is whenever this is equal to 0. So 0 to the 1/3 is going to give you 0. Another way you can think about it is just do the third power on both sides of the equation, right? Take the third power. That way we cancel the two powers, and now you have x minus 4 equal to 0. Right, so either way, it's just whatever is inside the power, inside the exponent. And we can see that this is going to happen when x equals 4. So here's your critical number. Critical number. That's it, right? So we found the critical number. So in this case, right, a is equal to 4. So we're going to be looking for these two intervals. It's separated by positive 4. All right, so let's move on to part B. Part B is asking us to find the interval whenever the function is increasing or decreasing, right? So we already know what to do for that. What we need to do is create a number line. and use the critical number to help us determine that, right? So we got 4x f prime of x. We know that at x equals 4 is no longer 0, right? This is no longer 0 because that's not the case in this example. Whenever we try that case, that didn't give us anything, right? So this is the case where the derivative is undefined. So finally we have one of those problems, right? So let me highlight this because that's a critical number. And we know it's a critical number because we end up getting one of these cases, but also because 4 is in the domain of the function, right? That means if you plug in 4 in here, you end up getting a real number, right? So let's try plugging a number. So number on the left side of 4 is 0, and a number on the right side of 4 is 5. So let's try to find out whether this is a positive or negative. Positive or negative. So all we gotta do is test the left side. So let's go ahead and do that. So let's take the derivative. We know it's going to be what, 6 over x minus 4 to the 1/3, and we're gonna plug in 0. That should be easy to determine. And we're gonna plug in 5. And again, we're only looking for whether this is positive or negative. All right, so 6, we know it's positive, right? 0 minus 4 is negative, raised to the 1/3 is going to be negative, right? The next one is positive. 6 is positive. This is going to be equal what? 1. 1 to the 1/3 is going to be positive. So, and you can try that, right? You can plug in negative 4 to the 1/3 power in your calculator, and that's going to give you a negative number. All right, so we have positive or negative implies negative. Positive or positive implies positive. So that means we're going to go ahead and use that information to fill up our space over here. That's negative, 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 positive, positive, positive. And by conclusion, the function is decreasing and increasing on this side. Here we know it's going to be a corner, right? That's going to be a corner because the function is undefined. Or it could have been also a vertical line, right? It could be a vertical line. So to find when the function is increasing, we're going to say it's increasing or it's decreasing from negative infinity to positive 4. We can see that from here, negative infinity all the way to 4 is decreasing. And from 4 to positive infinity, we can see that from here to, that's going to be increasing. Okay, so we have negative. So that would be, according to this will be decreasing. From this will be in, oh, I wrote it in the wrong place. Oopsie, it's up here, right? So from negative infinity to positive 4, that would be decreasing. And from 4 to infinity, this will be increasing. And there you go, we found that. So next part is to do part C, and we're gonna find where is the function concave up or concave down. Just like we did in the previous problem, we need to figure out what is happening in the second derivative, and just like we did before, we're gonna use a number line, but we need to separate, or we need to break down the number line, and so for that we use whenever the second derivative is 0. So we already know what the second derivative is in this case. That's going to be second derivative is equal to, well, we have to take the second derivative. So where are we at? Over here. So we have the first derivative was 6 times x minus 4 to the negative 1/3, right? So let's take the derivative of the derivative. So 6 times x minus 4 to the negative 1/3, right? So let's take the derivative of the derivative. What does that mean? It means we use the power rule along with the constant multiple rule. So multiply those two. So 6 times negative 1/3 times x minus 4 raised to, and what do we do here? We subtract 1. So if you subtract 1, that's going to be negative 1/3 minus 1. You use your calculator, that will give you negative 4/3. Alright, so if we simplify this, these two simplify to be negative 2, and this has a negative power, so we're going to bring that down. Alright, and so we're going to find where this is positive or negative. So we're going to find out, actually we also have to find out where this is undefined, right? So that would be the other one. So in this case, this is never going to equal 0, right? Can this equal 0? Well, no, because that means that the numerator has to equal 0, and we know that negative 2 cannot equal 0, right? We know that this cannot equal 0. So remember that this whole thing can only be 0 whenever the numerator is set equal to 0. So that's not going to happen because negative 2 cannot equal 0. So let's try the second one. That will be whenever the second derivative is undefined. And that's going to happen whenever the denominator is equal to 0. So this will be undefined whenever the denominator is 0. And just like before, we're going to use the same logic and say, well, this is only going to be 0 whenever this is 0. So 0 to any power will give you 0. But any number raised to any power will never give you a 0, right? So this has to equal 0. Or you can just do the raise this to the power of 3/4, and that will give us x minus 4 equals 0. So anyways, and we can add 4, and we end up getting x equals 4. And we're going to use that as a number line to help us break the number line. So let's try that here. So we need to test both sides. We already know what happens at 4 for the second derivative. This is going to be undefined. So we need to plug in a number on both sides of the equation. So this will be 0 and 5. 0 and 5. So let's plug in that into the second derivative. So second derivative is given to be negative 2 over x minus 4 to the 4/3. Can I say something here real quick? Well, if we know that this is being raised to the 4th power, what we can do here is have the 1/3 there and raise this to the 4th power. We can do that because remember that 1/3 times 4 gives you that power. So what I'm trying to say here is we already know what's going to happen because we know that negative 2 is always negative, and we know that the bottom part is always going to be positive because you're raising that to a positive power. So negative over a positive will be negative. And so in other words, this is negative, 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 negative. So we have a concave down, concave down, concave down. And that's it, right? So both cases are concave down. So from negative infinity to 4 is concave down, and from 4 to positive infinity is concave down. Now, if you guys didn't were able to follow what I said here, you can just literally plug in 0 there, and then get negative 2 over a positive number, which will be negative over positive is negative. Or you can plug in 5, that would be negative 2, 5 minus 4, when you, and which is, you're gonna get a positive number as well. So negative over positive is gonna be negative. So you end up getting the same result. So concave down for negative infinity to 4, union from 4 to positive infinity. And that's it pretty much for this example. All right, so it's the same process. Just gotta make sure that we are able to follow the steps and be able to be comfortable with this system. I recommend that you try your own style, right? This is my style. I kind of follow this style, it makes sense to me, but I recommend you trying your own style.